Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about direct proportion. The concepts of direct proportion and inverse proportion are very useful and very important in a lot of applications. And in this video, we're going to talk about direct proportion. In the next video, we're going to talk about inverse proportion. If you have two quantities, whereas one quantity increases by a certain factor, so does the other, or as one quantity decreases by a certain factor, so does the other, you would say that those two quantities are directly proportional. And the way that we set up a direct proportion is always going to be the same. On the other hand, if as one quantity increases by a certain factor, the other quantity decreases by that same factor, we would say that those are inversely proportional. So right now we're just going to focus on direct proportion. One easy example to understand is when you work and you get paid for your work, the more hours you work, the more money you get paid. We won't get into any complications like overtime. So for example, if you knew what you got paid for a certain amount of time, if you doubled that time, you can expect to get double the pay. We're going to take a look at some examples, and we're going to look at how we set it up, and we're also going to talk about how we know it is a direct proportion. So let's get started. The first example says, on a 3-hour car trip, the cost of gas is $35. How much would it be for an 8-hour trip? The assumption here is that the average speed is going to be the same for both trips, and also that the cost of gas is going to be the same for both trips. So assuming those things don't change, if we drive 8 hours instead of 3, so we're increasing the time that we're driving, we can expect the cost of the gas to increase by the same factor. So when you set up a direct proportion, you set up a ratio of the two values. So if we have a 3-hour car trip costing $35, I'm going to set up a ratio of the money over the time. From that, you could just calculate how much per hour you would be paying. But instead, I'm going to set up a proportion where I'm going to say that ratio, that cost per hour, should be equal to, if I put the price in the numerator, I have to put the price in the numerator, and I don't know that. If I put the time in the denominator, I have to put the time in the denominator. So that's how a direct proportion is set up. I'm going to ignore the units. I'm going to set it up again without the units. So 35 over 3 should equal x over 8. Once it's set up, you can cross multiply to solve. So to solve, we're going to have 3 times x equal to 35 times 8, 280. And then to solve for x, I'm going to divide both sides by 3. So for an 8-hour trip, we can expect that the gas will cost $93.33. I'm going to tell you a little shortcut for solving this type of equation when you have a direct proportion. What you can do is simply take the two numbers that are diagonal to each other and multiply them, and then divide by the number that's diagonal to the x. So in other words, take 35 times 8 and divide by 3. So you don't have to go through the next couple of steps if you want to take that shortcut. Let's take a look at some more examples. Our next example says a steel bar 20 feet long weighs 12.5 pounds. The question asks, how heavy is a 30-foot long bar with the same diameter? So we're working with a longer steel bar. We would expect the weight to increase by the same factor. Therefore, we know it's direct proportion. So we set it up, 12.5 pounds over 20 feet will equal, we don't know how many pounds, over 30 feet. From a mathematical point of view, it really doesn't matter whether you put the weight over the length or the length over the weight, as long as you do it in the same order on the other side, because when you cross multiply, you'll get the same result. But you might want to put it in this order, because then when you think about that, if we were to do this division, that would tell us how many pounds per foot of length. But it's just a minor detail and really doesn't matter. So that constant, that ratio should be the same for both pieces of steel. Now we're going to drop the units. So 12.5 over 20 will equal x over 30. Cross multiply, so we're going to take 12.5 times 30, and then we're going to divide by 20, and we get 18.75 pounds. Did our units have to be in that order? No. We could have done 20 feet over 12.5 pounds equals 30 feet over x. As long as both numerators are in the same unit, and as long as both denominators are the same unit, then when you cross multiply, you're going to get the same result, and you can try it. So choosing which one goes in the numerator and the denominator, it's up to you. Just make sure it's in the same order on the other side of the equation. Let's try a couple more. Our next example says a worker can assemble 10 parts in 30 minutes. How long would it take that worker to assemble 40 parts? So again, we're assuming that that worker continues at the same rate of work. If we're talking about the worker assembling more parts, we would expect that the time would increase by the same factor. Let's set it up. 10 parts in 30 minutes is equal to the ratio of 40 parts in x minutes. So in other words, 10 parts in 30 minutes equals 40 divided by x. We cross multiply, 30 times 40, and then divide by 10. So we would get 120 minutes. It will be the same unit, the time will be the same unit. We probably would express that as 2 hours. We could have worked with our time in hours to begin with. We could have had 10 parts over half an hour. 30 minutes is 0.5 hours, equals 40 parts in x hours. So we could have worked in parts over time and hours, number of parts, time and hours, and when we cross multiply, we'll get 2 hours that way as well. It doesn't matter as long as both units for time are the same, as well as both units in the numerator are the same. Let's do one last example. This question says a 12,000 BTU air conditioner will cover an area of 400 square feet. How many BTUs are required to cover an area of 1,500 square feet? So air conditioners can be measured in BTUs per hour, or can be measured in tons. We're going to just work with the unit that's given, and we know that a larger room is going to require more BTUs, so we know it's a direct proportion. So we can set it up. The capacity of the air conditioner over the area of the room. And we could calculate, well, how many BTUs are required per square foot, and then proceed. But we're just going to do it as a direct proportion. So we know that that has to equal the number of BTUs, which that's what we're finding, to cover 1,500 square feet. If you write it without the units, it looks easier. We could simplify before we start as well, but if we were to cross multiply that and then divide by 400, we would get 45,000 BTUs. So as you can see, there are a lot of applications for direct proportion. I use it all the time. How do you know it's a direct proportion? Well, you ask yourself the question, if I were to increase one quantity by a certain factor, will the other quantity increase by that same factor? Or if I were to decrease one quantity by a certain factor, will the other quantity decrease by that same factor? If the answer is yes, then you know it's a direct proportion. Practice these as much as you can. And in the next video, we're going to move on to inverse proportion. So when you're ready, I'll see you then.